Welcome back to the channel, guys. In last video we have seen about classes and objects. So in this video we'll be concentrating about OOP concepts. So what is OOP? OOP stands for object oriented programming. So what is object oriented programming? Object oriented programming stands for object oriented programming. Here in the sense we know the concept of objects, right? So objects are nothing but real world entities. So keeping these real world entities in our mind, how will orient the program, how will implement the program, how will write the program. So these principles or core idea or core concepts behind the object oriented programming are known as OOPS concepts here. So to name a few, they are encapsulation, inheritance, polymorphism and abstraction. A easy way to remember these concepts is that as remembering a p I e, pi. A for abstraction, P for polymorphism, I for inheritance and E for encapsulation. So this is an easy way to remember that. So coming to the encapsulation part. So if you guys have gone through my previous sessions, I've explained why we will make certain, not certain, this is a convenient way of programming. We will make the data variables as private and we will give a setter and getter method for that data variable so that other classes can access those data variables. So this type of programming, while providing the data variables as private and making them access through getters and setters, is a way of restricting the access, right? Of course, we are not like providing the other classes to implement our classes data variables publicly. What we are doing is that we are letting them to access through methods. So there's an access restriction here. So this type of programming concept is known as encapsulation, where we will bundle the data methods and data variables into a single class and restrict the access for that. So it is known as encapsulation, simple as that. And let's go to inheritance part now. So what is inheritance? So inheritance is a mechanism to create a new class using the properties and behaviors of the existing class. So let's take a real world scenario here. Suppose there is a parent, a mother and father, having a single born boy or girl, okay? And this single born boy or girl has the ability to inherit all the assets. These assets can be in any form. It can be in the currency or it can be in the form of acres of land. These properties present in the name of the parent class or parent can be inherited by the child class or children's, right? So this is the mechanism of inheritance. So why we need inheritance? Suppose let's say in the programming idea, why we need inheritance is that there are thousands of classes and lakhs of methods present in those all classes combined, right? So tomorrow there is an additional functionality to a class named X. A customer comes and he says, for the class X, add a functionality or a methods of 10 different functionality or 10 different methods and add 15 extra variables, right? He will tell that. What am I going to do now? Will I go and search the entire classes to find that X class manually? Obviously not. We are programmer. We like automation, right? We will not do that. So what the simple idea here is that we will use the extends keyword here. Using this extends keyword, we will extend the base class or the X class which we need, and we will name a certain A class, A or B, any name. C class, let's consider a class named D. Yeah, anything. Let's consider class named D, and this D class will extend the X class, and that for new functionality and new data required by the customer, we will implement in the D class, and we will extend the what? The X class. So the functionality present in the X class is present to the D class, as well as the new functionality required by the client is also present in the D class. That's the catch here, but not vice versa, meaning that the D class methods and variables will not be available to the X class, but the X class methods and variables will be available for the D class. Please have a catch of this, guys. This is very important. And coming to the polymorphism. So the word poly stands for many, as you guys will be knowing. So ability to take many forms. The polymorphism stands for the ability to take many forms. So what is this many forms? So here also let's take a real world scenario here. Suppose there is a customer. He comes and tells you, the programmer, to write a calculator program that only accepts integer type of data, right? Let's take addition in our scenario. You're performing an addition program and it only accepts integer type of data. There is a method called as add. Okay, and it returns also integer type of data. Tomorrow the same customer comes to you, the programmer, and asks to add a different functionality to upset the double type of data. So what the catch here? So obviously the logic remains same, only the data needs to be changed, right? So what you guys will be doing here is that the same name will be given to the method, but with different data types. The signature will be different, meaning that the parenthesis or parameter which takes the method will be different and the return type will be different, but the functionality will be same, right? For that, why need to implement the different logic? The same name, the same class will be using, right? So what we will be doing here is that the same name will be given to the both the methods, but the parameter will be different. We'll see that through an example so that it will be clear for you guys. So and let's come to the abstraction part. So what is abstraction? Let's take a real scenario again. So I need a certain brand mobile, and I will go to a store, and the marketing team or the salesperson explains to me in very convenient or many, what to say, compiling way to me, such that I'm tempted to buy that product, right? So for me, the core working of the mobile is not important. Suppose the seller says that it's latest version of processing system, it's octa core, hexa core, like that. Of course, I will be not knowing what is octa core and hecta core if I'm a normal user. What I require is that if the speed is increased, if the download speed is increased, if the networking speed increased of the mobile, I will be just simplified with or convenient or compiled with the normal key terms, right? So what this seller will do that he will tell complex things for me, but I will not be understanding it. So that's just an abstract idea, meaning that I just need an abstract way. Just a minute, guys. Abstraction. So what is abstraction? Suppose say I need to buy a new phone, right? I will go to the store and there is a seller. He convinces me of everything. He will say fancy terms and everything, and he will convince me to buy that product, right? Of course I will be convinced by him. So what he will be telling me is that it's the latest process, it's an octa core, hexa core, etc. I will say. So of course I will be convinced, I will buy the product. So he's just giving the abstract idea. He's not going and telling me how the processor or how the octa core is different from the previous cores in the processor, etc. I will not tell. He will just tell that the CPU clock time is increased, the networking speed is increased, the download speed is increased, etc. like that. So of course I will be convinced. Similarly, how we will represent those abstract ideas in the programming word, like without providing the deeper knowledge of that, the program needs to understand only the abstract idea about that. The detailing will be provided by the other clients if required, right? Like that. So this is known as abstraction. How we will implement this abstraction, we will see that. So it's implemented using abstract classes and interfaces. So in coming to the programming word, abstraction meaning that they will be method, there will be method definition, that's all. Meaning that there will be, for example, void a method name parenthesis, and there will be no definition of that. It is abstract, right? There is no definition, there is no implementation of that method, it's abstract. Similarly, there will be an abstract class and there will be methods in that, or they may not be methods also. A simple class with a beginning parenthesis and ending parenthesis, abstract, yeah. They may or may not be a detailed implementation about that class, but there is a class. Similarly, what is an interface? So coming to the interface, so interface is a blueprint for classes. This is a general term for that. So what is interface? Interface is nothing but inside interface there will be certain methods, right? And there will be no body for the method, there will be no implementation for the method. That's need to be keep in mind, guys. Yeah, that's interfaces. Let's go to the dev environment IDE. Let's start with the encapsulation, guys. So what I've done here is that I've taken a class known as employee. Obviously employee will be having name and age, and its type of string and int. So what is the catch here is that I have made this both data variables as private. Private in the sense the other classes cannot access them directly, right? So if I need to access, how will I access? So using these getters and setters. I use it get name, I use the set name to set the value of this variable, and get name to the get the value of the variable, right? And this public indicates that anybody or any class can access these methods. The same thing which I am doing the example class. Yeah, what I am doing is I am creating the object of the employee class, and I am storing in a reference value emp. Using this emp, I am setting the name, I am setting the age, I am getting the age, I am getting the name, right? and if you print that, obviously that's what I'm doing. Let's run that. Yeah, obviously John Doe because I'm setting that, 30 because I'm setting that. Yeah, let's go to inheritance now. Inheritance, as I told, a parent and child relationship. So here let's go to in depth here. Let's consider a normal class as animal. Yeah, animal can be any animal. It's a generalized idea, right? So animal will be making sounds. Obviously animal makes sounds. So there is a method which tells that this is a behavior of animal. The animal will make the sound, right? Animal makes a sound. Okay, and there is a dog. So this dog is a child class or subclass, right? What this child or subclass will be doing, how will we know this is a child class or subclass? Using this extends keyword. If we are using this extend keywords, the compiler of the Java program will come to know that this is a child class of animal. Extends animal meaning that all the features, all the methods, all the data variables present in the animals can be used by the dog class, but not in reverse, right? But not in reverse, meaning that suppose say there is a method called void abc, right? There's a method called void abc. So this method will not be available to the animal class. Animal class cannot use this abc, but this sound method is available in the animal class, right? Yeah, and it's really used by the dog class, right? And this is known as method overriding, meaning that because there is already a method with the same name present in the animal class or parent class, we are using that in the dog class or subclass or child class. It's known as method overriding. And we need to use the at override annotation here. So what is this annotation? We'll be seeing in the future classes, nothing to worry about that. Yeah, we need to use this override, meaning that at compile time there will be no issue. The compiler will come to know this overridden method. So once I execute or once I call in the main method, yeah, this is the main method. As you guys will be knowing that the execution of the program begins with the main method. Yeah, so here the execution will begin. What I am doing here is that I am creating a dog object and storing it in the dog class reference variable, of course, and I'm calling the sound method, right? I'm calling the sound method. Obviously let's go to dog class. Of course there is a sound method and this will be called. Obviously this will be called, right? Dog bars need to be outputted. Let me run. Yeah, dog barks is the output. I think the idea of inheritance is clear. Why we need inheritance, how to use the inheritance using the extends keywords, keep that in mind. So let's jump to now inheritance. Let's go to abstraction. Let's go to abstraction. There's an abstract idea, right? So similarly, let's take similar example, animal. In animal, as I told, abstract class may or may not contain what? Methods. So here there is a method. An abstract class is perfectly alright even if there is nothing, right? If there is no definition for the class also, it's alright for the abstract class. The compiler upsets it, right? There's no error as you guys can see. And it can also take what? Methods as optional. Here in our case we have taken two methods. There is a regular method, a sleep, where of course animal will be sleeping. That's the core idea behind is that animal is sleeping and animal makes the sound, but there is no what? Definition for that. Definition mean like there is no implementation like this part for this method. So for that we need to use the keyword abstract, and for class also we need to use the class abstract. So if I take the abstract keyword here, there's a warning shown by the compiler. What is that? The abstract method sound in type animal can only be defined by the abstract class. That's what I told, guys. Keep in mind, for in order to make the compiler understand it's an abstract class, we need to use the keyword abstract, right? So that the compiler understands this. Now there is no error thrown by the compiler. As simple as that. So similarly here also there's a dog which just overrides. This is an inheritance concept guide, extends keyword. So here also we are doing nothing but we are creating an object of the dog class and storing the reference value of dog variable. And what we are doing is that we are calling the sound and sleep. Just as simple as we can run that also. Let me run it. Of course dog barks and animal is sleeping because animal is present in sleep class. As you can see that there is no sleep class here, right? But it's the concept of inheritance, right? Sleep is present in the animal, so obviously animal sleep will be called. That's the inheritance capability, guys. It's very needy and required at times. So Let's go to polymorphism, one name many form. Let's go to compile time polymorphism here. So what I have done is that, as I told, there will be customer coming. So for first requirement or first sitting here told that he need to add two numbers and it only upsets integer type of data. I have done this code, and later it comes and it told it needs to be done in the double form also, meaning that floating point data. So for that, the same name is the right, same name many form. This is the polymorphism. Same name, two method with the same name but different return type and different arguments. So how the compiler will be knowing this? How the compiler will call? If I call the method with add, how it will come to know? Yes, correct guys. It will come to know using the parenthesis, or it will come to using the parameters which we pass. Let's go to the example here. So here I am creating the object of the math util class and I am storing in the util class, right? So here the compiler will come to know if I am passing the integer type, it will come to the class here and it will call the corresponding integer type of parameter. It will match and it will call, right? So it is known as compile time polymorphism, meaning that at compile time it will come to know, the compiler comes to know. And here if I pass the double type of data, obviously at the compile time the compiler will come to know I need to call this method, right? Not this. So let's go to runtime polymorphism. So what is runtime polymorphism, right? So same example of animal and dog. There's an animal class which takes sound as a method or behavior of that animal, obviously, and there is a dog which extends animal. This is an inheritance concept, and it overrides the sound method present in the animal and it prints dog barks. So what is this runtime polymorphism of all things? So what I am doing is that while at the time of creating the dog, right, at the time of creating the dog, now the compiler will be like it will be having a confused state, which sound to call. Should I call the animal sound method, or should I call the dog sound method? Which to call? So here comes the runtime polymorphism, guys. So I am storing this in the dog reference variable because this is inheritance concept. The child class object can be stored by animal class because I am extending the functionality of that. I think it's clear. I am calling sound, right? It will bring dog barks. It will print dog barks. Why not animals? Animals make sound because we are overriding. At override we are using at override, meaning that this functionality will be not called, this functionality will be called, right? That's why we're using the annotation at override. So runtime polymorphism here is that the compiler will come to know about this which method to call. Like there is a conflict, right? Which method to call? This will be cleared by the compiler at the runtime. So this is known as runtime polymorphism. Nothing fancy in that. So in the times yeah, let's go to interfaces, guys. As I told, interface is nothing but they are like blueprint for classes, like the there's a saying. Let's go to animal. So animal is an interface, meaning that they are methods inside that. They are all methods, but there's none implementation given to that, meaning that there's a sound method, right? There's a sleep method. Obviously animal sounds and sleeps, but there is no what implementation or the definition for these methods. So it is known as interface, and in order to define interface in Java, we need to use the keyword interface. If I use a class for this, what will happen is that there's an error thrown by the compiler, says that the method requires a body instead of semicolon. Yeah, that's why we're using interface here. So now the compiler knows that is an interface. So similarly in the dog, yeah, this dog is nothing but inheritance concept implements. So this is not inheritance, right? We are doing inheritance, we are using extend keyword. So what is this? This is implementation, right? An interface implementation concept. What is this? So there is an interface animal and we are implementing this animal interface. Okay, how the compiler will come to know? Using this implements keyword. So in order to implement the methods in the interface to your class, or suppose say there is an interface with certain methods, I want to implement them or I want to provide functionality to them. See, there is an interface here which the interface named as animal, and there are methods for that such as sound and sleep, but there is no definition. So what I will do as a programmer, I want to give them the definition. How I will do that? I will create a class and I will use the keyword known as implements, and I will give the name of that particular interface. So now I have the access for those methods and I can provide the interface implementation here, like the dog barks and the dog is sleeping, right? Like that. And at override we should use at annotation it overrides the parent class methods, right? Like that. So interface example, yeah, I've created the dog object in dog, and I'm just executing those things. Let me run those. Yeah, dog barks, dog is sleeping. Yeah, I think that's all for today, guys. So I will be coming with the concept of arrays and strings in the coming videos. If there are any doubts or any suggestions, please to comment down below. So I'm happy to take any suggestion, and stay connected, guys. Thank you for watching. We'll see you with the next videos. Thank you. Bye bye.